Hello, maths lovers. The topic for today is sword, as you can see on the board. So basically, on this particular video, what I'm going to do is to explain what sword is, and secondly, write the rules, explain the rules of sword, and thirdly, solve basically examples on the addition and subtractions of sword on this particular video. Then in my next video, I am going to do multiplication of sword and rationalizations of sword, which is basically the division of sword. So let's get to it. Now, first of all, before saying anything, I want to explain what um, rational number is. Rational numbers are basically numbers that can be written in the form a over b. A over b. So examples of these particular numbers are 1 over 2, 2 over 3, 5 over 7, 100 over 1 million, and you have numbers like that. So basically, rational numbers are numbers that can be expressed in a fractional way. Okay? Now, what is irrational numbers? Irrational numbers are numbers that cannot be expressed in this particular form. So, example is pi. That is 3.14159 with some other numbers like that. Also, we have what root 2, we have root 3, we have root 5, we have root 7, we have root 13, we have root 17, and it goes on like that. Those numbers cannot be expressed in this particular form. So they have their own ways of what operations. That's why what I'm going to do next is to what write the rules of sword. Now, all these numbers that I've just mentioned are called sword, are basically generalized as what sword. They are all irrational numbers. So generally, sword is an irrational number, or the root of what an irrational number. So let's get to what the rules of what sword. So there are two basic and major rules of sword, two of them. So rules of sword, rules of sword. So the first rule is, if we have AB, now if you have a number just like an AB, the AB here represents a particular number. It could be 12, it could be 20, it could be 30, and so on. Now we find what the factors of that particular number, two factors that can be multiplied to get what that same number, which is what AB. So we have something like this. We have the root of A multiplied by the root of what B. Then we can also what individually get the root of the first number and the root of the second number, which is what the root of what A multiplying what the root of B. Now this is the first rule. Now the second rule is, if we have A divided by what B, like this, A in bracket A divided by B, like this. Now this can be written in this form. We have A at the top and B just like a fraction, A over B, and these roots can be split individually. We have the one at the top, that's root A at the top, divided by what root B below. So these are the two basic rules of sword. So I need you to note that A plus B is never equal to A plus B is never equal to the root of A plus the root of B. Is never equal to the root of A plus the root of what B. Also, this is 1, 2. Also, A minus B is also never equal to what the root of A individually minus the root of what B individually. So there's nothing like this in sword. There's basically nothing like this and so. So now let me write an example for you to understand the rule. Understand the rule. So I am going to focus on the first rule in this particular video, and in my next video I will do a lot of examples on the second rule. So I'll clean the second rule and leave the first rule. So example, simplify. Simplify, we have 1 root 72. We have 2 root 500. And we have 3 root 490. 490. Okay? So solution. Now, the first one, which is what? The root of 72. Now, like I said initially, you find two numbers that when you multiply them, you get what? 72. And make sure that one of those numbers is a perfect square. What I mean is this by perfect square is this. Root 4 is 2. So root 4 is actually a perfect square. That's 4 is a perfect square. Root 9 is 3. 9 is the perfect square. Root 16 is 4. 16 is the perfect square. Root 25 is what? 5. 25 is the perfect square. Root 36 is 6. That is 36 is a perfect square. Root 49 is 7. That is 49 is a perfect square. So when you are multiplying, you find one of those perfect squares and include in your multiplier. So we have in this case we have 36 times 2. 36 times 2 is basically what? 72. So this is this. So just like what we have in this particular rule, as the first rule, we split this root. So we now have the root of 36 times the individual root of what? 2. So this is now basically equal to what? So 72. The root of 72 is basically equal to what? The root of 36 is 6. So we now have 6 times what? The root of 2, which is equal to what? 6 root 2. So this is our answer. Okay. Now the second one, which is what? Root 500. Root 500 is also simple, same method. So I'll use this black pen. We have root 500. Now 500 is the same thing as what? 100 multiplied by what? 5, right? So we have the root of what? 100 multiplied by 5. Now if we split this root, we have what? The root of 100 multiplied by the root of what? 5. So that means that what? The root of what? 500 is now equal to what? The root of 100 is what? 10. And 5 is an irrational, root 5 is irrational. So we have 10 times what? The root of what? 5, which is the same thing as what? 10 root 5. So this is our answer. Now the last one, which is what? Root 49. 49 root 490. So we have the root of what? 490. Now root of 490, 490 is the same thing as what? 49 times 10, right? So we have 49 times 10 to be equal to what? The individual root of what? 49 times the individual root of what? 10, which is the same thing as what? So root 49 is what? 7. Root 10 is irrational. So we have what? 7 root 10 as our answer. So this is just an example to show you how to go about what? Finding the factors and applying this first rule. So let's now move straight into what? The additions and the subtractions of what? These are basically the questions that I'm going to use in explaining the additions and subtractions of what? Surds. So let's get to it. So solution. the first one here is what? 2 root 125. Now I will just go straight to solving because of space. Now, first one. Now the root of 125. 125 is something as what? 5 times 5 times 5 in what? 3 places, which is what we can equally say we have 25 times 5, right? Now 25 is a perfect square and 5 is irrational, so we'll keep that. Also 45. 45 here is 45 here is what? 9 times 5. 9 is a perfect square. So we have 9 times the 5. So 5 is already 5 there. So we'll just let that be. So we have 2 long roots. We have our what? 25 times what? 5 as 125. Plus this is it. Now for 45. 45 is something as what? 9 times what? 5 minus. We now have 8 root 5. Okay. Now, if we split this root, just like what we have in our rule, we have 2. This implies we have 2, the individual root of what? 25. 25 times the individual root of what? 5. So I'll put this in bracket plus put this one also in bracket. So I have the individual root of what? 9 times the individual root of 5. Also in bracket minus 8 root 5. So this I will not put in bracket. So 25 is the same thing as what? Root of 25 is the same thing as what? 5. So we now have what? In bracket we have 2 times what? 5. So root of 25 here is 5 times this root 5 here, right? Also in bracket plus the root of 9 is 3 times root 5, close bracket, and we have minus 8 root 5. Okay, so 2 times 5 is what? 10. So we have a 10 root 5 here. Same thing as 10 times what? 10 times 5 plus this is 3 times what? The root of 5 minus 8 root 5. So this is basically what? This is 10 root 5 plus this is 3 root 5 minus 8 root 5. Now looking at this, this is 10 root 5, this is 3 root 5, this is 8 root 5. Now the form here is they are all 5, 5, 5. All the roots are carrying 5. So we can confidently factor out 5, right? And the numbers outside the root, we can add them up and do our subtraction. So what I'm saying is this. So we can put a bracket here and write this 10 here, this plus here, and the 3 here, the minus here, and the 8 here. Close the bracket and put our root 5 outside. So that is what? That is a factorization that I'm talking about. So that 5 plus 3 gives us what? 13. 13 minus 8 is what? 5. So we have 5 root 5 as our final answer. 5 root 5 as our final answer. So the major thing is to what? Find 2 factors or 2 numbers, particularly one should be a perfect square. You're multiplying to get what is inside the root, just like what is inside this root is 125. Likewise this, and likewise the other. So let's jump into number 2 questions. Now number 2 is, now we have 18 here, we have 54 here, we have 108 here. So 18 is the same thing as what? 9 times 2. So this is 2 the root of 9 times what? 2. There's a plus, so this is a plus, and there's a 2 here, and 54 is the same thing as 9 times 6. So I have 9 times what? 6 minus 108 is the same thing as 9 times 12. So we have 9 times 12. Okay, so if we split this, we have, this implies we have 2 here. Let me put it in bracket also. We have the root of 9 times the root of 2, close bracket, plus also this in bracket, we have 2 the root of 9 times the root of 6, close bracket, minus also this in bracket, the root of 9 times the root of what? 12. Now mind you, the root of 12, 4 times 3, so 4, so that root 4 is 2. So let's continue. This is what the root of 9 is what? 3. So we have 2 times 3 times the root of what? 2, plus the root of 9 here again is 3, so we have 2 times what? 3 times what? The root of 6, minus the root of 9 here again is 3, so we have 3 here times what? The root of 4 times 3, which is 12. Okay, now this now implies 2 times 3 is what? 6. So this is like 6 root 2, 6 root 2, plus this is also 6 root 6, minus, now this is what? 3 times root 4 is same thing as what? 2, so this is root 3. So finally we now have this as our answer: 6 root 2 plus 6 root 6 minus what? 6 root 3. This is our answer. So that is generally our what? Answer. We have 6 root 2 here, we have 6 root 6 here, we have what? 6 root 3 there. So now let's do the last example now we have. So the last example, number 3, is the root of 99 minus the root of 44 plus the root of 11. Now, root of 99 is the same thing as what? 9 times 11. Root of 44 is the same thing as what? 4 times what? 11. So 11 is just still there. So this implies we have the individual root of 9 times what? 11 minus the individual root of what? 4 times 11 plus root 11. Now, root 9 here is, if we split these roots, we have 9 times root 11 for this bracket minus this bracket, the root of 4 times the root of 11, close bracket, plus the root of 11. All right, so the root of 9 is 3, so this is like 3 root 11 plus this is 2 root 11 plus what? The root of what? 11. Now this has a 3 here, this has a 2 here, that means this particularly has 1. So if we factor out all the 11, we have what? Open bracket, we have 3 here, plus we have 2 here, plus, oh, this is minus and 1, close bracket, root 11. So this is equal. So 3 minus 2 is 1. 1 plus 1 is 2. So finally our answer is 2 root 11. This is our answer. Thank you guys for watching. I would really appreciate if you share the video to your friends, your classmates, and your loved ones. Thank you, and see you in the next video.